I'm going to give it a minute or two for people to join. Thank you to all of you who are joining us for this virtual town hall. My name is Tanya Verkaitis, and I'm the Executive Director of PSRPA. Over the past few years, over this past year, we hosted town halls in communities across the state, highlighting our radioactive emission study, flare optical gas imaging, and our air monitoring project. Unlike the in-person town halls where we highlighted the potential health impacts for specific communities, today we'll share information from across the state. A few housekeeping notes: please put questions in the Q&A. You can find the function at the bottom of your screen. Though we'll do our best to monitor the chat, we cannot promise that we will see all questions. Feel free to utilize the chat, however, for any comments and resources that you'd like to share. PSRPA was originally founded to oppose nuclear weapons. In the 1990s, PSRPA shifted to apply its medical expertise to environmental health issues in recognition that global climate change and toxic pollution also pose grave risks to human health. Today, we focus our work in three main areas. That's climate change, environmental health, and youth mentoring under violence prevention. You can learn more about our work at www.psrpa.org. For today's agenda, we will talk about the radioactive emission studies, flare optical gas imaging, air monitoring, and then we'll open it up for Q&A. Now, I'll pass it over to Tammy Murphy.
Hi. Thank you very much for joining us today. I'm Tammy Murphy. I'm the Advocacy Director at PSR Pennsylvania, and I'm going to be talking to you about radioactivity and health. So we can go to the next slide. We have for years now been trying to change the conversation in Pennsylvania and beyond when it comes to fracking, talking about jobs and the economy, and we were trying to switch it over to talk about the health impacts of fracking. The morbidity and mortality of these projects are known in advance, and the compendium now has thousands of studies showing that fracking cannot be done safely. On the right side of the screen, you can see our current infographic, which is an update of an older version that was very popular. I think this update includes the more recent studies, and it's actually quite a bit easier visually to see. So that's available on our website if you're interested in it. We can go to the next slide. When we were trying to change the conversation, when I first started, we always saw headlines about jobs. Fracking was always related to jobs and the economy, and you really couldn't talk much about it unless you were saying how wonderful it was for jobs and the economy, which has largely been debunked by the Ohio River Valley Institute. But what we see currently in the headlines is more about how fracking is making Pennsylvanians sick. And as Dr. Katayer said, we are all at risk, and the risk is significant. We can move to the next slide. A couple of years ago, we came across a unique opportunity to work with Justin Noble, an amazing investigative journalist, and an awesome team of researchers, Dr. Mark Baskaran and Paul Mannion from Wayne State University, who study radionuclides, and Dr. Marcia Haley, an oncologist with UPMC in Pittsburgh. Our study was the first of its kind. We took air, water, and soil samples across much of Pennsylvania, from the areas where hydraulic fracking, also known as fracking, is happening throughout the pipeline transportation process and even to where it is stored and exported. So as you can see on the right, on the top image of the state, there's a lot of yellow and red. That's where the extraction is happening, and it goes covers in the west and across the north of the state. And then if you look at the map below that, there's a crisscrossing of pipelines throughout the state, and that's the transportation, which often brings it to the to the eastern side of the state, where there's a lot of exportation and storage process happening. We are going to get into some of the details of what the study found, but for now, let's get into some of the basics about radiation. We can move to the next slide. Thank you. Alpha, gamma, or alpha, beta, gamma. You can see here the different types of radiation and how they are able to penetrate in order to cause exposure. So alpha is rather basic, can be stopped by something simple and solid, as even as flimsy as a piece of paper. And then as it goes down the list, it's more and more penetrable. We can move to the next slide. We're talking about norm and T-norm because radioactivity actually happens naturally. So it's called naturally occurring radioactive material, which happens below the surface of the earth, deep down in the earth, and it's natural process. We have plenty of it here in Pennsylvania. People are, familiar with things like radon in their basements and being concerned about that. It's a normal occurrence. What's abnormal is what's referred to as technologically enhanced naturally occurring radioactive material. Technically enhanced is a funny way of saying that they bring this naturally occurring radioactive material up from the underneath the surface to the surface, which actually, is, I wouldn't call it enhanced because it's not like they change it in any way other than the fact that more people are exposed to it. It's more easy for it to impact people. So we can move to the next slide. When we get into talking about the levels of radioactivity that we found, there's a couple of things that we need to focus on. One of the main things that came out of our study was the fact that the radioactive emissions were occurring not only in the area, if you can think back to the map from earlier, where there were extractive sites, but also, and we did our study this way on purpose, we started out in the area that's heavily extracted. The fracking is, commonplace out there, and it's all in very close proximity to each other. And then we moved across and tried to do facilities across the state where there was no extraction and there was just the pipelines and the storage spaces and compressor stations and things like that to push the transportation along. And I think all of us expected to find higher limits in the higher emissions in the extractive area and fewer emissions in the area away from the extraction, and that's not really what we found. It was pretty consistent, and I'll try to show you that on the charts. But and there's an explanation for that too. But the thing that really came out of it for the most part for me and for others that are focused on the health perspective of it is that the legal limits are, if you're looking here at the radium-226, the legal limit is 5 picocuries per liter. And that's in stark juxtaposition of the public health goal, which is 0.05 picocuries per liter. So there's vast space between what is legal and what is considered safe as far as public health. There's a vast difference, and that becomes really problematic when you look at this, and we'll get a little bit more into the details. If we can go to the next slide. The emissions and exposures, we found low levels of radioactive emissions throughout the state. We're in the extractive regions and in the areas where it's transported, stored, and exported, which is to say that there is a low, slow, continuous dose that people are exposed to. And that can happen in places that are close to your school or places that are close to where you work, and then also in your home or close to your home. And having this continual slow, low dose is, because the legal limit is so much higher, I think that it was considered maybe that it wasn't so dangerous, but the reality of that low, slow dose, especially if it's continuous and it's in a place that you repeatedly go to, or if it's in your home where you live all the time, is that the body never really has an opportunity to recuperate. So most of the standards, and I'll get a little bit more into detail of, but the standards are set for people that aren't experiencing this on a constant, regular basis, without, protective gear. So we can go to the next slide. The different types of radioactive emissions have different health impacts, and the radium 226 and 228 are related to bone, liver, and breast cancer. Radon is related to lung cancer. It's the second leading cause of lung cancer in this country. Lead, people have often heard about lead poisoning. It does have behavioral and mental health impacts. Polonium is a decay product that is found in the pipes. And that's one of the reasons that we found, or we presume that we found, where there's an extractive area where the radiation is being pulled up frequently, and also in the pipelines, which are kind of far away from that. But what we realize is that the radioactive material attaches itself to the pipes. So in that waste and in the pipes, in the transportation of the process, the radiation doesn't actually go away, it builds up. So we can go to the next slide. And this shows part of our study that was very interesting. Almost all of it, if you look at the bars to the right, almost everything was at this level, which is like somewhere around 4 picocuries per gram. Roughly everything was in that sort of range across the whole entire state, except for 2 different locations. There were 2 different outliers, and in Washington County, there was a really stark example of an outlier. So I showed that on this chart just to let you know that there were a couple of outliers, but almost everything else throughout the state was consistent. We can go to the next chart to look more detail into Washington County without the outlier there. So then you can see that they're more even, removing the outlier, and that the levels are, here they're looking like 3.5, like close to picocuries per gram. And that was roughly the same throughout Washington County, which is a very heavily extracted area, the most heavily extracted area in the state, actually, in fact. So this was pretty consistent throughout. And like we know the legal limit, as we said, was like 5. And the public health is 0.05. So these are well above the public health guidelines, but they still do fall within the state legal limit. We can go to the next slide to look at a different type of area. And this, we did our study and included Westmoreland, which surrounded, a lot of it was surrounding the Max Environmental landfill, which receives radioactive waste. And there are other landfills that in other areas in our state, like in the Scranton area, that also receive radioactive waste. Lackawanna and others in the state receive this. So this, although we didn't study that, you can apply the same basic concept here. You can see the levels here. Again, they are well below the legal limit, but they are well above the public health goals. And that was in Westmoreland County, and that was a landfill. If we go to the next one, kind of moving eastward across the state, and in Chester County and Delaware County, what we're dealing with in those communities are lots of pipelines, compressor stations, pumping stations, and the radioactivity, as I said, is attaching itself to the pipelines and to the facilities. So it's getting attached to the actual facilities, and so it's not decreasing the way that most of us expected at the beginning of our study. So these are the levels there, and they're a little bit higher even than in some of these cases than over by the landfill, and even some of the charts that we saw in Washington County, where it's extremely heavy extraction. The radioactivity does not reflect, the emissions happen across the board. So the thickness, just to be clear, the thickness of this graph is just because there's fewer samples in the slides. If we go to the next slide, some of the problem with having such a disparity between the legal limits and the public health limits is because a lot of us would have expected our federal government and state government to to protect us from these. And because we hear of things like the Safe Drinking Water Act. We can actually go to the next slide, gives a little bit more detail, but I'll kind of go over it. There's tons of exemptions and limitations. So we hear things like the Safe Drinking Water Act, so we think our water is clean. The Clean Water Act, again, same thing. Resources Conservation and Recovery Act. There have been so many of these over the years that most of us think whatever is permitted must be under federal guidelines that keep us safe. And even if those guidelines exist with exemptions and limitations that are, all over the place in the oil and gas industry that are taken advantage of, it's really actually like these loopholes that allow us to get exposed to these chemicals that we are kind of under the guise of thinking that we're safe from, and we're not. We can go to the next slide. I think a lot of people, especially we're talking about jobs, jobs, jobs in the economy, because everyone who was so supportive of fracking seemed to be so concerned about workers' health. It's actually that in fact, that the OSHA, which is supposed to protect laborers, there's tons of exemptions there. And actually, radioactivity was deemed non-hazardous in the 80s, which is really just false. It is quite hazardous. And that really reflects the difference between the legal limits, which are largely for people that are like working in an 8-hour shift in protective gear, or some experience where you're on a site for a short period of time and then you go back home to your house, where there's supposedly not radioactivity. The guidelines are meant for those kinds of scenarios, not the low, slow dose that we saw in our study. So these exemptions actually cause a lot of problems, and I'll share a couple of quotes in our next slide, which is my last slide. I think this is very interesting. There's no federal agency that specifically regulates radioactivity. That's the TNORM that's brought to the surface, and that's directly from the EPA. And then the Natural Resource Defense Council actually stated that legal gaps leave fracking a radioactive mess. So this is actually happening all over our state, and because it's considered non-hazardous, you're not going to see the same placards on the trucks as you would if it was carrying it to a nuclear weapons or a nuclear energy facility, even though it's the same material. So that I will conclude my presentation on that. And thank you again for joining us, and we're happy to answer some questions afterwards.
Hello, everybody. My name is Christina DiGiulio. I'm going to be talking about thermography and optical gas imaging. But first, on the next slide, I wanted to transition from what Tammy was talking about with radiation and show you this is one of the pieces of equipment I use. It's called a Geiger counter or radiation meter. And when Tammy was talking about OSHA and the protections to workers, here at PSR, I carry a dosimeter, which actually calculates how much I have been, like the dose, or how much I have accumulatively, like, basically been exposed to. And I think this is what workers have to be using these on site to see when things are hot, and as well having a dosimeter on it, which I believe they do not. It's not required. So, this is it's called the IMI Inspector Alert. It's really awesome. It looks at alpha, beta, gamma, and X-ray, and this is a wonderful suggestion of Justin Noble. So I'm very happy that we have this. We just got a new one. It's called a BLE, and it actually tracks and GPS locates everywhere that we get a reading in like a 5-minute interval. So we're going to get a nice map of what Pennsylvania looks like when we're traveling around on the roads with the Geiger counter. Next slide, please. All right, so back to thermography. So what is camera do that I have? It is that we have, it's forward-looking infrared. That's the FLIR aspect of it. And then what we have is a spectral filter, a specialized camera that is looking at it's an optical gas imager. And so this camera is specialized to view specifically here hydrocarbons, one being methane, as you guys know, called natural gas, which it's not natural gas, it's methane. As a chemist, this is what we say. We use the real name, say what it is. And that's what it's doing, is seeing the absorption on the electromagnetic spectrum, and it's absorbing around 3.3 microns, or basically methane comes out at, or hydrocarbons are coming out at 3.2 microns to 3.4 microns, or micrometers. Next slide, please. And this is what I was just speaking about. This is the electromagnetic spectrum. And as you can see, methane and propane are here. It basically is falling right into the range. I'm not going to be able to see carbon dioxide. I'm not going to be able to see other, you know, compounds. But what it is looking is in the mid infrared right here. And when we talk about infrared, and thermography, it's basically we're looking at the thermal signatures of things, or the thermal differences in things, and that would be heat. So as you can see, we see in the visible light spectrum, which is right on the spectrum in the rainbow. So we see a very limited amount of the electromagnetic spectrum, and this camera is just looking at one part of it, being the mid infrared. Next slide, please. So the camera I specifically use is a GFX 320. It's from Teledyne FLIR, and it is an intrinsically safe camera, meaning it will not cause an explosion if there's combustible gases at a concentration that would, you know, any kind of an ignition source would cause. This camera can actually go into enclosed areas and not cause a problem. And over to the right, you're going to see a list of the hydrocarbons that this camera is validated to see. And there's a large list of them. So where a lot of people are typically hearing propane, butane, and methane. This thing does see benzene, you know, isoprene. As you can see, all these wonderful hydrocarbons that are in our air. Hopefully not. Next slide. And that's what we're going to look at now. Is I was out in Washington County in Buffalo Township, and this is an OGI, optical gas imaging of the Range Resources Brownlee Michael pad, and we'll just play for you. And I want to also make the map next to it is basically a 1 mile radius where there are schools with this site. And I don't think you can hear it. Are people able to hear the dictation on this or not? Or should
I don't hear anything.
Okay, good. Then I'm going to talk. So right now we see a circle. This is an active fracking pad. And where I just had a little circle pop up is where I need you to focus right now. Because you can see the tower to the left. That's the tower they're fracking with. But over to the right, we're seeing a plume of a hydrocarbon, which this camera sees hydrocarbons. I can not speciate nor quantify it. But that green, blue, and the right, that is actually a release. I'm not sure why it is happening, but as we know in active fracking, this is some of the most dangerous stuff coming up. It's probably the crap they don't want. And it's just being released into the air as they're fracking. I don't know if there's regulations on this, if this is allowable, but what this camera is seeing is both, again, you see the sky is red, it's hot. So the spectrum and the palette that we're looking at, it's called the rainbow palette. And what you see in the greens, when we get into the greens, is cooler and blues. So, all right, so we can stop that video. And I want to just go back to this map next to it on your right. And this is done by Jody from Center for Coalfield Justice, a really great map, because when we did the PIT and DOH studies, they were talking about the 1 mile radius of health impacts for lymphoma, childhood lymphoma, and asthma. So what we did was she marked the site and then put a 1 mile radius buffer, a zone around it, and you can see everything that does fall within that 1 mile. And there are schools, as you can see, the high school up on the top of that map. So next slide. Pretty scary. Okay, so that was an active well pad. Now we're going to go to a compressor station. And this is the Carpenter compressor station in Donegal, again, Washington County. And again, looking at that map to the side, the right side of the video, you can see the 1 mile radius, and that there are, you know, public areas, public places that are within a mile radius. People work there and live there. All right, if you could press play. So this is a large compressor station, and there is a lot of emissions coming out of it, I'll say that. So when we see these dark stacks, so this is our visible, when we see the dark stacks, when I switch back into the thermography, that's heat. The dark is hot. and the lighter is cooler. So these are obviously functioning. You can see like what's considered, it looks like smoke coming out. So this is high sensitivity mode. That smoke looks kind of like a 3D. That is actually uncombusted hydrocarbons coming out. And there are one, two, three, four. There's at least, I know in this site 6 sources that are emitting. I think they have internal flare stacks next to this as well. So what we're looking at is hydrocarbons that are not being fully combusted. And this is a very far like compressor station, but I wanted to show it because it is, and I was moving over to the left there, and that's where there are 2 internal flare stacks, and you can see a heat signature. What I wanted to show is like when you see the big dark ball above something, that's a heat signature. And obviously these gases are hot, and so when you start to see it dissipate, it's like losing its heat as well, but you still can see the hydrocarbon. It looks kind of like a strange kind of cloud. And we'll get a better image of a closer compressor station I have on the next one, so we can move on to that. So these, remember, these are all in one county, and I'm showing you a bunch of compressor stations. We have to talk about how all of these are permitted to release based upon their, I guess it's a class 5 permit. And the problem I have with that is that there's nobody actually doing stack tests. I think it's 1 every 5 years, or even 1, if we're lucky, it's 1 a year. And a stack test is what tells you what's actually coming out of these stacks, or of a flare stack or anything. These things are supposed to operate within a certain tightness. 98% of the hydrocarbons are to be combusted, and they're allowing 2% supposedly, or 1.5% into the air. And that's what these are calibrated supposedly to emit. And I'm not convinced of that from what I'm seeing. And then if you talk about having several of them in one area, so if we press play on this one, think about that. There's several of these facilities in one county, and there's no invisible wall stopping hydrocarbons coming from one. Again, you can see the map on the right as well, showing that there's an overlap of 2 facilities, and public places are located within those 1 mile radiuses. This one's interesting because there's actually a worker working on the stack. You can see that JL lift right there. There's actually a worker on that, and he's working on a, I think it's an internal flare stack. Now you can see him still there working, and it's dark black. That means it's hot. And as well, you can see the hydrocarbons that are not fully combusting coming out. And in some points I was watching this downdraft into the gentleman's face, and he did not have a respirator on. So when Tammy was talking about OSHA and whatnot, this is just, I mean, this guy had to be working there for an hour, and this is just, and you see it right now blowing into his face. So what you're seeing is uncombusted hydrocarbons coming from this. These are flare stacks. These are pretty much, when we have a system of pressurized hydrocarbons, the system has to release at some point. There's no way to stop methane from escaping because it's the nature of the actual process. There has to be, buffers for a overpressurization. So you'll have release valves. Now I'm going to move over here on this video. You're going to see me moving over to the compressor station roof. And as you can see, you see the cloud. When you see that really dark, that's the heat, that's the heated gases, and then it's dissipating, and you're still seeing like a smoke that's non-combusted hydrocarbons that are coming out. And there's 2 of these that are active. The other thing we can do with this camera is tell you how many of the compressors are working in a particular station. I don't always see them running 100%, but they are always emitting every single time. I've seen this, which now going to high sensitivity mode, you can see that plume up there. It's pretty, that's a lot, in my opinion. I don't think this is, I don't know if this is 2%. We will not know unless we had somebody up there testing it, which, it takes for these things to work at the threshold that they're certified to work at. There's so many factors, and they have to be able to do this. Like, they have to have everything calibrated properly. They have to know the temperature, and everything has to be adjusted for these things to only allow 2%. And I doubt that it's happening at all times. So one of the frustrations I have with this is if you're letting self-regulate, this industry self-regulate, haven't we seen enough of how they do that? And this is going into the air of all of us. So remember, this is this is the second or third compressor station I've imaged in this area in one county. So we could stop and move on to the next video. And I believe that's going to be another compressor station. All right, you can press play. And again, to the right, you can see that there is public facilities within a mile radius. And now we have 1, 2, 3, 4 different sources in this compressor station. And you know, the ones that are on the roof are actually the non-combusted hydrocarbons coming from the compressors themselves. The one that you see on the right and lower is one of those internal flare stacks, supposedly. This is me assuming that I cannot get onto the properties, obviously, but from what I understand, you know, this is a safety feature for when there's pressurization in a compressor station, and these things have to be, there's a pilot, so they're always running, but this one is actually combusting, not fully combusting the hydrocarbons. So this is changing out to a different palette, which, you know, makes it pretty clear. Again, we can see the heat at the very you know, point of the source, and then you see the dissipation of that heat, and you're seeing hydrocarbons after that. So that's 3 compressor stations now, and all of them are emitting in one county. So next is going to, I believe, be the well pad. This is an interesting one. This is in, again, Washington County, and this is on a farm, but has several residents that have complained of smells, in fact, have gotten ill in the valley here. So if we press play, I can show you that I pretty much was, with the permission of the property owner, I was able to get up pretty close to it, and I'm going to show you how I showed up and there was nothing going on, actually. And this is the visible, and the flare, there it is. That's what we're focusing on. As you can see, there's nothing going on with that. So I'm going to pan over and show you the rest of the well pad. There are workers, there's their trucks, and then you see these tanks. The other thing we can do with this thermography camera is see the level of fluid in those tanks, which you can see on the left one. It's less than half full. So another feature we could use this for. So when I move and scan and pan back to, now it's on. Now there's stuff coming out of it. Hydrocarbons not combusted fully. And this is another feature that I feel like was part of a legal suit, correct me if I'm wrong, but Range Resources has been, has gotten a little trouble for releasing hydrocarbons just directly out of a pig station, which is terrible to have to do in a neighborhood of people who live there. So now this is their, I believe this is their mitigation for that. So they have pressure problems, I guess, in their lines, and they're trying to get rid of, they have to release. And they're required now to burn it, but it's not fully combusting. But this goes off at it. It's only allowed to happen for a certain amount of time per day. So it is either on a timer and goes off every, you know, like hour, or it's based upon the pressurization. But legally, they're not allowed to be releasing for a certain amount of time and a certain amount of times a day, like the volume of you know, of the hydrocarbon, which is kind of gross. It's right there's people who live right next to this. So next one is going to be moving on. The other thing we do with OGI is we have been doing a lot of work on orphan and abandoned wells, which everybody has seen to be a major problem in Pennsylvania. Or we have the well plugging program. So if we press play, I'm out here, and this is up in Hillman State Park area, Hanover Township, Washington County again. And the first one we're going to see is the SB Donaldson 2. And this is a well that's from the 1800s, has a wooden casing, and it is just openly leaking in the front yard of a resident who also has children there, and has been since they moved there. So that's what we're looking at, the circled area, and you can see it's just emanating out of there, out of the ground, and it has been since they've lived here. And you can actually, there's enough concentration for that to light on fire. So it looks like a little candlestick. I've seen them do this. So this is, and that's actually probably blowing towards the house. So this well is currently being plugged right now as we speak, which is pretty interesting. I'm happy because they prioritized a leaking well on somebody's property that has children. This is a AB Donaldson 5. This is in a stream, a waterway of the Commonwealth. And what we're seeing is both a thermal convection. How does this mean like a colder amount of water? Colder water is meeting warmer water, but it's also showing hydrocarbons in the water coming from this well. Not just that, there's oil sheens everywhere around here. So this is another 1800s well, wooden casing, it's leaking, and it's in a waterway contaminating the waterways of Pennsylvania, which as PSRPA, we did make a formal complaint to this well specifically, and supposedly they are working on it. That complaint is not closed yet. Do not allow them to close them until they have an answer. And so you can see the people were trying to basically trace source to figure out where it's coming from. And when I, it's too long a video, but when I was in the stream, I traced it all the way back to the well. So it's on the side of and on the bank of the stream. It's pretty gross that this is happening. And there are thousands and thousands of these wells that are just leaking. Hillman State Park has a really big problem. So, they're supposedly the DEP is working on it, and we're going to do our part is to try and image it. And you can see it in the water. It's like methane in the water. It's pretty neat to be able to capture that. So I believe that's my last slide. And hopefully, if you guys have any questions, we will have them at the end.
Thank you, Chris. All right. I am going to speak a little bit about our air monitoring project. As Chris pointed out, we're seeing tons of emissions across the state. And because of this, we actually want to capture as much data as possible about what type of air quality people are experiencing at home. So we started this project about a year ago. You can see all the spots on the map. We actually have a lot more monitors up now. We have approximately 52 monitors across the state of Pennsylvania, and we're inviting residents to ask us for monitors, and we'll come and put them out. With this online system, you can actually look at air quality across the state. You can click on any of these placards and see what the air quality is for that community. When you open the placards, you'll see the AQI. You can look at the past month, the past 7 days, the past 24 hours, and the color coding here makes it very clear what days had good air and what days had poor air quality. Another thing you can do with this system is add notes about what's occurring in your community. So this family has been very responsive to the system. They add photographs, they talk about what it might smell like outside. Here she notes that they drove to the bus stop this day because the air quality didn't look very bad, but members of the household had dry, scratchy throats and they were having trouble breathing. We want to invite you all to participate in the air quality monitoring. There's more information on the website. And if you're interested in getting a monitor, just email info@PSRPA and we'll be happy to get one over to you. Now we'll open it up for questions. I hope you can see everyone since I removed the spotlights, but let me see what questions are here. So the first question, and I guess this is for you, Chris. Yvonne works for a local nonprofit in Southwest Pennsylvania. They're looking for a radiation detector that can pick up radiation in streams as well as air. Are you aware of anything that does this? And if so, can you share?
For air, obviously, there are, Justin Noble is actually talking about a constant air monitoring system. It's in Colorado. Tammy, if you remember what he was talking about, that was a study. There is a group there that does constant radiation monitoring. There's one type of monitoring. You could have the handheld version, like I have the IMI Inspector Alert, which obviously will do air, and you can swab and inspect things for radiation. When it comes to water, I'd have to call the company. You cannot put this meter in water, but it might be able, you might be able to pick up something off of the swap if you swap the water and present it to it without getting the water in the detector. I'd have to look into that. But other than that, you'd have to get quantitative analysis, like having water samples taken and then analyzed in a lab for, you know, confirmation. So I hope that I answered that. All right, there are cheaper ones and there are for, you know, meters. If you have any more questions, let us know. I can give you some details on the ones we have and other ones if you'd like.
Another question for you from Sydney. He's wondering, is there a way to quantify and speciate, I guess, the carbon or hydrocarbon emissions from these images?
Yeah, I think Tammy did a good job answering that in the chat. So I will just reiterate it for everybody. Yeah, so this camera currently, no, as what it is possible. That's the first. Yes, it is possible to do this. We could do it with our camera with a lot of work and possibly a $20,000 add-on software. However, the new, I don't typically think we need that software, but we're just going to go with that's probably the safest. And the new cameras, the GF 320 series, are actually, they have an internal system. They now have quantification and and I don't know if they're speciating. I'm going to say quantification, but through quantification, there should be ability for at least some kind of speciation. I'm not sure what the certainty is in it. But yeah, it's totally possible. And that's through Teledyne, FLIR, probably other makers of this too. So it's kind of one of the limitations of the camera. I feel like they have figured that out. And you know, there's so many different types of instruments out there that can, you know, measure this stuff. So this camera needed to have the speciation and the quantification, I think, for it to be a whole package effective deal for the cost of it. So
Thank you.
I'm just going to put in the chat now the reference. Sorry, I'm just grabbing it now. To the group in Colorado. They're called Boulder.
yeah.
And that's run by somebody named researcher named Detlev Helmig, and they do have these larger permanent facilities that monitor air consistently. And they really seem like they're very interesting and very cool, but they are not the kind of thing that you can get like a cheap handheld thing. But if you have the opportunity to work with Detlev, if there's like a grant or something like that to get this kind of a monitor, it's something that we would be, you know, really fascinated with too.
Yeah,
Be really
definitely.
helpful.
That's Tammy's talking about, like there's qualitative analysis, like, but it's like quantitative. Having constant air monitoring also gives you so much more information as to like where the facility is or how bad it is. Like having that information I'm very happy they're doing this. Thank you for sending that out, Tammy. But this is I think the next step in radiation monitoring, especially around landfills and whatnot. So, but handhelds work.
Thank you both. I believe those are all of our questions. So thanks to you all who are participating today. The recording will be on the website so you can share it with others, and have a great rest of your week.
Yeah.
Bye, everybody.
Thank you for joining.